Alright, boys and girls, welcome to our first video lesson in Chapter 2, 2-1, Quadratic Functions. Okay, let's go back to Algebra 2 for a minute and let's review our family of functions. Let's start with our most basic function, the linear function, going back actually to Algebra 1 here. Linear functions have the equation, as you know, y equals mx plus b. And they're going to look something like this if you graph them. Okay, we can talk about a direct variation function. A direct variation function is also a linear function that passes through the origin. So the b is going to equal 0, so it's y equals mx. Sometimes we write that y equals kx. And it is a function that passes through the origin. Looks like that. We can talk about a constant function. That's where it's a linear function where the slope is 0. So y equals 0x plus b, or just y equals b. And it's going to look, of course, something like this. And also a very important function, which we talk about when we talk about the inverse function, is the identity function, which is just y equals x. It's also, of course, a linear function. It's also a direct variation function. And it, of course, looks like this. And it is the line that we reflect our inverse graphs over. Okay, we got the absolute value functions, which is y, and we'll do it in vertex form. Y equals a, absolute value, x minus h plus k, where hk, of course, is the vertex. And when we graph this puppy, it makes a V of some sort. Of course, it could be upside down or anywhere else. But our vertex is at h comma k. We got the greatest integer function, and I'm hoping you did this last year at some point. It is a step function. It's in the form y equals a greatest integer, x minus h plus k. And it's going to be a series of steps when we graph it. And if you haven't done this last year, don't worry about it too much. We'll talk about it this year. And lastly, most importantly, because that's what we're doing in this section here, we got the quadratic functions, which are parabolas, which of course can either be in the form y equals ax squared plus bx plus c. That's our general form, or we can do it in vertex form, also called the standard form, which is y equals a x minus h squared plus k. It, of course, makes a parabola. We'll do it like this. Whoop, there's my parabola. And this vertex, of course, is h comma k. That's a k. Whoop. Okay, let's get into our quadratics. Quadratic equations comes, as we just said, in general form or in standard form. General form is in the form of, if it's an equation, ax squared plus bx plus c is equal to 0. Or if it's a function, y equals ax squared plus bx plus c. Okay, down here we can see, just to review, our quadratic term is the x squared term, or the a term. Our linear term is the x term, or the b term. And our constant term, the c term, is x to the 0 power, or it doesn't have an x. It's our constant term. In standard form, or vertex form, I like to call it vertex form, it's y equals a times x minus h squared plus k. Or if some people like to put the k on the other side by subtracting k from both sides. We won't do this too often until we get to conics. Okay, but of course h comma k is going to be our vertex. You can also factor a quadratic equation. If you factor the quadratic equation, you get our roots form. You still have the constant a, and the a is the same in each of these three equations. A will always be the same number, but if we factor our quadratic, we're going to see our roots, which would be x1 and x2, and this we sometimes just, as opposed to roots form, we just call factored form. Okay, let's look at a picture or the graph of our quadratic function. They are a parabola. They make that U shape right there. Okay, this point down at the bottom, where our graph turns around, is called our vertex. It, of course, is in the form h comma k. So that's our vertex. In green, the mirror image of our parabola, a vertical line passing through the vertex, is going to be our axis of symmetry. Sorry, that's the best I could do with my Marshall Mellow pen. And of course, the 2 points where the parabola passes through the x-axis, these 2 points right here, these are my roots. These are my roots, which of course we also call the x-intercepts, or the zeros. They are the solution or the answers to our quadratic equations. Okay, there are several ways to find the vertex of your parabola when it's given to you in general form. The way you probably remember the most is to use the equation x equals negative b over 2a. That's going to give us our x coordinate, and once you've got that x, we plug that into our function to get our y. So if we have the equation right here, y equals 1/4 x squared plus 3x plus 2, a, of course, is equal to 1/4, b is equal to 3, that's 3 in Spanish, and c is equal to 2. So to find my x coordinate, I'm going to take my b, which is 3, so I got negative b, negative 3, over 2a, 2 times 1/4, which equals now negative 3 over 2 times 1/4 is 1/2. 3 over negative 3 over 1/2, x equals neg 6. Once I have that neg 6, I'm going to plug it in to my equation to get my y. So y is going to equal 1/4 times 6 squared plus 3 times 6 plus 2. 6 squared is 36. 1/4 of 36 is 9. Plus 3 times 6, which is 18, plus 2. So now my y is going to equal 9 plus 18 is 27, plus 2 is 29. The vertex of this parabola is at negative 6, comma 29. You can also, and we'll do this in class, you can also find the vertex by completing the square, and by completing the square we convert our equation to standard form, or HK form, which gives us our vertex at HK. We'll do this in class. Or you can use your calculator, and of course I'm hoping you remember how to use your calculator to find the min and the max. To do that, you're going to do second calc. Whoop, I need a pen here. Second calc, which is second trace, which is our calc, and you go to max or min, depending upon whether our parabola is right side up, you would find the min, where if it's upside down, you're going to find the max. Okay, in order to find the graph, or to graph a quadratic equation, sometimes we want to find our critical points. Our critical points is going to be the vertex and the x and y intercepts. So I'm going to draw a quick little graph over here. Okay, first thing we're going to do is let's find the vertex by using negative b over 2a. Here our b is negative 4. I'll just write that right here. And our a is 1, because it's 1x squared. So negative b is negative 4, which is 4, over 2 times 1, which is 2. So our vertex is at x equals 2. I'm going to plug that in to get my y. So I plug in 2 into x squared. So I have 2 squared minus 4 times 2, which of course is 4, minus 8, which is neg 4. So my y, my vertex, is neg 4. So my vertex is at 2 comma neg 4, which we'll put down here. To find my y-intercepts, that's the easiest thing to do, and you guys know that. We're just going to plug in 0 for x. So I have 0 squared minus 4 times 0, which is 0 minus 0, which of course is 0. So I have my y-intercept at 0. And now to find my x-intercepts, what I'm going to do is I'm going to solve this equation. There's I'm going to let 0 be y. So 0 equals x squared minus 4x. We can factor this, so 0 equals x times x minus 4. Now we know from Algebra 1 that either x equals 0 or x minus 4 equals 0. So we already have a root of 0 right here on our y-intercept right here. We'll just put it in again in green. And then we also have a root of x equals 4. That's going to be right here. So my parabola, I'll do that in purple, is going to look something like this. Okay, you guys do this one for a minute. First of all, find the vertex using our negative b over 2a, and then plug in the x to get our y. Then find our y-intercept, and you're going to do that by plugging in x equals 0 into the function. And then I want you to find the x-intercepts, or the roots, by factoring this equation and solving for x. Go ahead and do your work. I'll be right back. I'm going to have a cup of coffee. Okay, let's start with the easy stuff here. You should have found your y-intercept was negative 10. You got that by plugging in 0 for x. You get 0 plus 0 minus 10. If you factor the function, you're going to get, of course, y equals, or 0 equals, you let y equal 0, x plus 5, x minus 2. So therefore, our y-intercepts, our x-intercepts, I'm sorry, are going to be at negative 5, positive 2. We have a y-intercept of negative 10. Okay, and now our vertex is going to be at negative 3 over 2a, which is 2, which is negative 3 halves. So x equals negative 3 halves. Y is going to equal negative 3 halves squared, which is 9/4, minus 3 times negative 3 halves, plus, which is going to be a minus, plus negative 3 times 3 halves is negative 9 halves, minus 9 halves, or I had the minus there, and then minus 10. Let's just approximate this real quick. 9/4 is 2 1/4. Minus 9 halves is 4 1/2. Minus 10. 2 1/4 minus 4 1/2 is negative 2 1/2 minus 10, so that's negative 12 1/2. So our y is negative 12 1/2. So we have a vertex at negative 3 halves, negative 12 1/2. Down here, our parabola is going to look something like, I'll do it in purple, this. Okay, let's take a minute here and solve this equation for x. In other words, I want to know what x equals, and it's actually kind of a trick question, because you know from the quadratic formula that when you have a quadratic equation in the form ax squared plus bx plus c, that x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can see now that there are always going to be two roots to a quadratic equation. Does everyone see the two roots here? Of course, it's negative b plus the radical over 2a and negative b minus the radical all over 2a. Okay, I will do this in class as well, but I want you to have it on tape because it's very important, because we're going to use this little property of quadratic roots again and again and again. It's called the sums and the products. What I'm going to do, just for the fun of it, I'm going to add these two quadratic roots. So if I add them, so I'm going to start by taking my first root, which is negative b, and I forgot that when I typed this in, but that's okay. So you just add it, negative b plus my radical, b squared minus 4ac, all over 2a. And I'm going to add that to my second root, which is negative b minus the radical, b squared minus 4ac, all over 2a. When I do that, I get negative b. I already have a common denominator, negative b plus the radical, plus negative b minus the radical, all over 2a. And we can see now what happens. My radicals can't cancel out, and I'm left with negative 2b over 2a. I can cancel those 2's, and when I add my roots, I get negative b over a. Alrighty, just for the fun of it, I'm going to do the exact same thing, but this time I'm going to multiply my two roots, and don't forget there should be a negative b in front of these. I forgot to put that in. So the first one, I'm going to start. So I'm going to do negative b plus the radical, b squared minus 4ac, all over 2a, times the same root, but this time it's the minus, negative b minus the radical, b squared minus 4ac, all over 2a. Let's multiply. Let's do the bottom first because that's much easier. 2a times 2a is 4a squared. And now up top, ding, 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 you should notice that we have conjugates. We have negative b plus the radical times negative b minus the radical. So you know it's going to be negative b squared minus the radical squared. So negative b squared is b squared. Minus the radical squared is going to be minus whatever is inside that radical, which you know is b squared minus 4ac. So what happens here when I distribute my negative, I get b squared minus b squared, and then distribute that negative plus 4ac. So I get on the bottom 4a squared. And up top I get b squared minus b squared, which is 0, plus 4ac. Well, 4a squared is equal to 4a. 4ac is 4ac. I can cancel my 4's, cancel my a's. And so when I multiply the roots of a quadratic equation, I get c over a. Okay, so what you can see now, when I take the two roots of a quadratic equation and I add them, that's the sum. When I add the roots of a quadratic equation, I get negative b over a. And when I multiply the roots, that's the product. When I multiply the roots of a quadratic equation, I get c over a. So now, as opposed to solving, we are going to take our roots of a quadratic equation and write the quadratic equation. As opposed to solving where we start with the equation and come up with the roots, we are going to start with the roots and come up with an equation. Let's do this the old-fashioned way first by writing this equation in factored form, or what we call roots form. Y equals a x minus x1 times x minus x2. Well, we don't know what the a is, so we'll just ignore that for a moment. But y equals, we'll let a be 1, okay? Because it really doesn't matter, and we don't know. X, my first root is 7, and my second root is negative 4. X minus 4 is x plus 4. And you know from Algebra 1, if I have the equation of y equals x minus 7 times x plus 4, I have a root of 7 and a root of negative 4. But now we'll just FOIL this out to get my equation. Y equals, we'll do this in green, x times x is x squared. X times 4 is plus 4x. Minus 7x minus 28, that's a negative 7 times 4. So what I have here is, we'll do this in blue, y equals x squared minus 3x minus 28. Okay, now let's take these same two roots, 7 and -4, and let's find the equation by using our sums and our products. First of all, let's add these two roots. 7 plus -4 is 3. So I know that 3 is equal to -b over a. And just to make my life easier, I'm going to write 3 as a fraction, 3 over 1. If I multiply these two roots, I'm going to get -28. And -28, that's my product. That's going to equal c over a. So looking at my equation, y equals ax squared plus bx plus c, we can see that a is equal to 1 because a is equal to 1. We can see that b is equal to -3 because -b is equal to 3. And we can see that c is equal to -28 right here. So my equation is going to be y equals 1x squared minus 3x, b is -3, and c is 28, and sure enough, that's the same answer that we just got. Okay, let's do this one more time. Now I have an equation that has roots of 2 plus root 3 and a root of 2 minus root 3. Let's do this the old-fashioned way by writing this in roots form or in factored form. Which is my roots form or my factor form. Let's again let a be 1. So I'm going to have y equals, a is just 1, so x minus 2 plus root 3 times x minus the second root, which is 2 minus root 3. If I dist my negs, let me put another parenthesis. So now let's dist my negs. I get y equals x minus 2 minus root 3 times x minus 2 plus root 3. All I did was distribute my negs here, right? Okay, now this is a triple FOIL. Who wants to triple FOIL? So instead, we're going to find this equation, given my two roots up here, using my sums and products. Okay, so let's first of all find the sum of our two roots. The sum is going to be 2 plus root 3 plus 2 minus root 3. So I have 2 plus root 3 plus 2 minus root 3. You can see that our root 3's are going to cancel out, and I'm going to have a sum of 2 plus 2, which is 4. So I now know that 4, I'm going to put it right over 1 right now, is equal to -b over a. My product is going to be, I'll do this in blue, 2 plus root 3 times 2 minus root 3. Hey, ding, ding, ding. What do we notice about 2 plus root 3 and 2 minus root 3? What are those things called? Conjugates. Very good. So when I multiply these out, I'm going to get 2 times 2, which is 4, 2 squared. My middle terms, I'm going to get 2, negative 2 root 3 plus 2 root 3, which cancel out. And then I'm going to get plus root 3 times negative root 3, which is minus root 3 squared, which is 3. So I have, when I multiply these, I have 4 minus 3, which is 1. So 1 over 1 is equal to c over a, the product of my roots. So now when I write my equation, I get y equals ax squared plus bx plus c, where my a is once again 1. My b is going to be -4 because negative b is equal to 4. And my c is 1. There is my equation. I should have just circled the bottom there. Y equals x squared minus 4x plus 1. Okay, let's do this one more time. I have roots of 3 and -0.4. Just to make my life easier, because this is easier, I'm going to let my -0.4 equal -2/5. Okay, so what I'm going to do is I'm going to add these two roots to get my -b over a. 3 plus -2/5 is going to equal, well, it's going to equal 2 and 1/5, or I can write this as 15/5 minus 2/5, which is as should have said 2 and 3/5, which is 13/5. So that's equal to negative b over a. If I multiply these two roots, I'm going to get 3 over 1 times negative 2/5, which equals negative 6/5. So that equals c over a. Now we can see that if I write this, y equals ax squared plus bx plus c. Our a is equal to 5. Our b is equal to negative 13. And our c is equal to negative 6. So I'm going to have y equals 5x squared minus 13x minus 6. And there is your equation given the roots of 3 and negative 2/5. That's all she wrote, folks. We'll see you soon and have a great night.